This is the first lecture in our look at the skeletal system from chapter 7. So we're going to start with the structure of bones. There are 5 general groups of bone. We usually classify them based on shape. I'm going to go to a picture here so you can see what I'm talking about. We've got long bones, which have a pretty distinctive look. They have a longer center portion and kind of rounded ends. There are short bones, which you can see here. This one's a little bit kind of generalized, not very much detail to it, but generally short bones are more square shaped than long. Obviously we have a lot more length here, and on the short bone it's about as wide as it is long. An irregular bone is just what it sounds like. We're looking for a bone that doesn't really fit well into any other grouping type. And then we have flat bones. Again, the name is pretty straightforward. It tells you what it is. So this is a picture of the shoulder blade, where the majority of the bone itself is flat. The only bone type we didn't mention here is called sesamoid. I'll write the word for you. Oh, no, I won't. Only if I can spell properly. Let's try that again. So sesamoid bones are basically floating. They're not necessarily attached very solidly to any other structures. The kneecap is an example, and it tends to be kind of a smaller bone that doesn't, again, fit into any of these other groupings. The bones near in the wrist and ankle are also considered sesamoid bones. So we're going to look a little bit at long bones in particular. And long bones, again, let me give you a little example here. This is looks like a baseball bat or a dumbbell, but anyway. Long bones, at the end of each long bone is a structure called the epiphysis. And this is the part of the bone that forms joints or aligns with other bone types to create places where the bones can bend and move more easily. At the ends of the bone, at the epiphysis, we talked about this the other day, there is cartilage surrounding a nice thick layer of a particular kind of cartilage called hyaline that helps to keep this friction-free and easy to rub against other bones without being painful. The mid part of the bone, or the shaft of the bone, is called the diaphysis. That makes up the length here. All around the bone, even underneath the cartilage, is a layer called the periosteum. Peri means around, osteum refers to bone. So this is a membrane that covers all parts of the bone, places where we have tendon connections and things. There's a little break in the periosteum, but otherwise it's a fairly solid, uniform structure. And so then if we're going inward on the bone, if we were to, say, saw this bone in half and then look at it from the end, on the outside part of the bone, we have a layer called compact. This is a really thick matrix that is very, very dense and very, very strong. And inside of that is a layer called the spongy bone. And there's even more volume, there's more layers going in, but we're going to stop right there for the moment. And the spongy bone increases as the length of this bone increases. So as you're growing, for instance, an example of a long bone would be the femur in your thigh. The amount of spongy bone increases as the length of your bone increases. So within the spongy bone itself, we've got a nice kind of diagram down here of these different parts, maybe a slightly better picture than the one I drew. So within the spongy bone, there are a bunch of kind of tiny plates that you can see in this picture really ever so slightly. It's right down here at the end. The epiphyseal plates are structures that kind of allow for compression and for some shock absorption that help to decrease the force on your bones as you are moving around and jumping and bending and doing all kinds of things that we do every single day. If your entire bone was compact bone, which is really, really tough and really, really strong, you would be so heavy. Your bones would be so heavy, you wouldn't really be able to move around very well. So every now and then we have these little places called epiphyseal plates that are lighter weight, but do kind of the same job. And then the innermost part of the bone, and you can see it here, the medullary cavity. This is a hollow chamber, believe it or not. It's kind of like a hallway running through a building, and it has bone cells called endosteum. They go on to make compact bone as more bone needs to be made and all kinds of other things. And they also house the bone marrow, which we will talk more about. So as we are looking at the bone, there are all kinds of different cells and all kinds of different little structures happening. If you think of a bone like, say, a skyscraper, there are bunches of little floors within that skyscraper, and within each floor there are hallways. Between the hallways there are apartments or whatever. And so your bones are very much like that as well. So the structure of the bone itself is called a matrix, and it's kind of like a webbing or a netting that provides the basic framework for the bone. This matrix is made up of inorganic minerals, things like calcium and magnesium and other elements that are strong and that can withstand a lot of force. And it's also made up of connective tissue and different proteins, particularly collagen, which is a very strong protein. Within the matrix, we have these little chambers, or think of these as your apartments. We have chambers called the lacuna, which is what you see up here, the lacuna, and they kind of provide the housing for the cells of the bones themselves. The cells that make up the bones are called osteocytes. Osteo again means bone, and cyte means cell. So the osteocytes live within the lacuna, and the lacuna are within the larger matrix of the bone. The important thing about osteocytes is they communicate back and forth from the outer edges of the bone to the inner edges of the bone. They pass messages, sort of like a game of telephone. When you were little, you'd whisper in the ear of one person and they'd whisper to the next. Osteocytes kind of do similar jobs. They have a little kind of communication network called canaliculi, which I know is a truly bizarre word. It's right here. And all it means is little canals. So think of the little canals as like secret passageways or tiny little openings from apartment to apartment where you, let's say you live next door to your best friend in an apartment and you want to pass them, I don't know, they want to borrow a shirt or something. So imagine that you have a little window or a little opening in your wall that you can just open and pass that message along without having to leave the comfort of your apartment. That's sort of how like the bones communicate from place to place. This matrix forms a larger pattern that looks something like this. I'm going to show you an actual diagram in just a second. And there are repeating patterns. So it's like a big, huge skyscraper that borders another big, huge skyscraper that borders another big, huge skyscraper, and on and on and on and on and on. And these big, huge skyscrapers are connected, or not connected, but sort of bisected by blood vessels and large nerves that then branch off and feed each one of these little areas. Each one of these skyscrapers is called an osteon. If you look at this picture right here, it's a kind of more organized version of what I just drew you, right? So you see these, a single osteon represents one single apartment building. Inside that apartment building of bone, we have different apartments called lamella with communication channels called canaliculi. And running down the very center, So picture this sort of like the elevator. It moves materials from the bottom of the apartment to the top. In this case, we've got large blood vessels running through the center of each osteon, which allows for lots of nutrients and oxygen and things to get all throughout the bone very easily. And then we just have these little repeating apartment buildings all throughout the bone. These are all happening in compact bone. Let's talk a little bit about how bones form to begin with. Inside the womb, while you are a little tiny baby starting to grow, there are a couple of different kinds of bone tissue taking place. So the bones of the head are developed initially as you are growing in the womb, and we have a certain kind of bone tissue forming there called intramembranous bones. This same type of bone repair is used for anytime you have a bone fracture, even when you are outside the womb as you grow. It's used to form the bones of the head because those bones are pretty soft and pretty pliable when you're first born, and then they change over time. There are also bone-building cells, again, osteoblasts, that come in as you are growing and deposit minerals into this soft bone structure and other hard parts and cells to help form that matrix into the kind of rigid structure that it is. Once that matrix is complete, then the cells kind of grow up and mature into their adult selves, which are called osteocytes. Osteo for bone, cyte for cell. And then the membranes around those osteocytes over time harden into periosteum, compact bone, and spongy bone, which is the structure that we talked about earlier. Once the bones are completely formed, they go from being kind of soft and more cartilage-like to being completely hard and adult bone formation. That whole process is called ossification, or the making of bone. There are some other bone development processes that happen. Again, when you're in the womb, we have bone-shaped structures that are not actually made out of bone. So your skeleton is made as a fetus out of cartilage, so it's kind of a little bit softer and somewhat more pliable than bone, but it's still in the same shape as the skeleton that you know of once you live outside the womb. This type of bone formation is called endochondral. So endo means inside, chond means cartilage, actually. And there are some animals, like sharks, whose entire lives are spent with a cartilage skeleton. But for humans, we only have that type of a skeleton when we are in the womb and very, very first born. So after birth, the shaft of the bone begins to release that cartilage. It starts to break down, and it gets replaced by spongy bone. While that is happening, the periosteum begins to form around the spongy bone, and it attaches to the connective tissue that already exists from the cartilage itself and from other connective tissue outside the bone. So picture a long bone here. And as this is happening, say it's starting in the center, and bone is beginning to form. And just like with skin, it forms kind of in one place, and then it pushes out toward the edges. So this is called the primary ossification center. Primary first, that's what primary means. Ossification means making of bone. This is the center where bone starts to be made. And as new bone cells are made, they extend out towards the ends of the bone, out towards the ends of the bone, and outward toward the periosteum. And all of this cartilage becomes harder and harder and harder and harder, and more and more and more bone-like. Down here at the end, we have the epiphyseal plates that we talked about earlier. They're also called the growth plates. And there will be little secondary centers of growth happening from the ends of the bone. And these secondary centers will start to grow inward. So eventually the two types of new bone tissue will kind of meet one another, and they generally meet at this point called the epiphyseal plate. And that's a location or a structure that's permanent in the body. Once the bone is completely formed from the ends toward the middle and from the middle towards the ends, that epiphyseal plate of cartilage will stay there for your whole life, and it can be seen on x-rays as you grow up. The epiphyseal plate is also important because it allows your bone to both thicken in strength and to increase in length, right? Picture the size of your femur, which is the long bone of the upper thigh. Picture the size of your femur at birth versus the size of your femur at adulthood, right? If your bones never got any longer, you would be a very, 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 very small adult. So the epiphyseal plate, in addition to providing a location for the primary and secondary centers to meet, it also allows for division to occur so this bone can get longer and longer and longer and eventually grow to its maximum length. It's a really important part of the bone growing process. Another thing that happens is as we age, old bone cells die, right? All cells die eventually. When the cells die, a special group of cells called osteoclasts, this basically means bone eaters. These are cells that come in and eat up the broken bone or the old bone. They break it down and then they recycle the mineral parts and all kinds of other cell parts into new cells. So blasts build, B for build, clasts, I don't know how you're going to remember that. I can't think of a good C word for eat or destroy, but at any rate, B, build, osteoclasts, break. So once the two centers meet at the epiphyseal plate, then your bone stops growing. The last thing that's important to talk about is how to keep bones healthy. The process of old cells dying and new cells being built happens all throughout our lives. That process gets less and less effective as we get older, and it can also be hampered by other factors in your life as you age. So one of the big factors is hormones, especially in females. Estrogen and some of the other kind of higher concentration feminine hormones tend to be really tough on blood calcium levels, and they tend to make it harder for the body to absorb calcium. Calcium is one of the big minerals that gives our bones strength, so we have to be really careful to make sure we're taking in enough calcium to replace that's being lost by hormones in the body. Vitamin D is another one that's important. Vitamin D doesn't actually help build bone in any way. All it does is it kind of acts as a carrier for calcium to be absorbed. If there's vitamin D in the right quantities in your body, it allows your small intestines to take calcium in and then pass that calcium to the bones. If you don't have enough vitamin D, it's hard for the body to absorb calcium. And in those instances, there are all kinds of diseases and conditions, like scurvy is one, and rickets is another. These are conditions where the bones become soft, and when bones become soft, just the pressure of moving around and the ways that we use our bodies can cause bones of the upper legs, for instance, to kind of bow and become deformed. There are also growth hormones that happen throughout your life that help to make bones the length they're supposed to be. Puberty has a pretty strong effect on bone growth. Generally, it promotes the growth of bones, although not always if the hormones in puberty aren't in the right proportions or are for some reason not being released properly. Things that you can control are exercise. Exercise actually really stimulates the strengthening of bone as well as the thickening of the compact bone itself. So exercise helps those bones to stay healthy and to build even additional strength. So those are all yours. wrap up our look at bones, here are your summary questions. Again, try and answer them as much as you can from memory. Make sure that you bring 3 discussion questions in to class, at least 3, for us to talk about, and anything that you need clarification on. And I will see you soon. Thanks.